Good afternoon, everybody. How are you? I just
Good
okay.
afternoon,
I was
Professor.
on.
Good
I
afternoon.
was. Hey, good afternoon, Peter.
Good
I just
afternoon,
got.
Professor.
Good afternoon, Eva. I just realized that I was muted, and then this happens all the time. Not realizing that I was muted. Okay, so I have four people in the collaborate session now, but let me check. Um, in the discussion board, I have three. So there is one person who hasn't signed into today's discussion board, right?
Yeah, that's me. I'm doing it right now.
Yeah, please do that before, um, because it's always, your responsibility to establish your own physical proof of attendance. Let me share my screen. All right. And this is today's forum. And all righty, only four people so far, but uh, look, I believe everyone is aware of the. Everyone must be. Everyone is aware of the practice test, right? Because that was posted. That was posted when. Yeah, this one. It was posted this Monday, right? And this announcement was posted this Monday.
So it should be available tomorrow.
Yeah, from 12 midnight tomorrow. So 12 a.m. a.m. 12 a.m. Not it's 12 midnight today actually. So um, you can't see it just yet because it's not it's not activated yet, but it is there. You can see. Uh, I also have. Okay, someone was asking. So I also took a screen grab of this. I mean, it's in the assignments folder. It's not available yet. You can't see it, but it will be visible from um, midnight tonight, or 12 a.m. Tomorrow morning. Right? Okay. All right. So it looks like I have seven people in the collaborate, and if you just came in, and I have, look, this is no good. Why, Dexton? I thought you, uh, Dexton. Yeah, this is the way. You have to establish it like this. And who else? Edgar. Edgar, are you here, Edgar?
Yeah, I'm here. I don't know what
Edgar,
I don't know how
you
to
have
create the
to.
thread.
Yeah, you,
I'm
you
trying to
should.
create.
Yeah, you must create your own thread because
I
otherwise,
don't.
because I'm checking it from, I'm counting the number of, I'm looking at this basically, and I'm, checking. Um, I sort it by the name, and I will mark my attendance roster based on this. Okay, so you must have your own thread.
All right, I'm trying to do that, but it's not like giving me the option to create
You see
thread.
where it says,
Well,
look, you see where
here,
it says
here.
up top to the left, create thread?
All right,
I was having the same problem. I couldn't
all right.
find it.
Let me check it right now. Hold up.
Yeah. Sometimes if you don't see that, that means you might need. Sometimes that happens, and that means you need to update your browser because sometimes the browsers are outdated, and sometimes these links are not visible. Okay. Um, all right. So we're gonna let me continue with our example from our last class. Remember, we were talking about the house value model, because I like this. I believe this is very pedagogically useful, because this is basically the idea of what financial assets or securities are all, how they behave. Uh, Although this is not an example of financial asset, this is a house value. But then I talked about scenario 1 and scenario 2. Remember, right? What is scenario 1? Scenario 1 is the case where you buy the house and use it as your home only, right? In that case, there is no extra income. There's no additional income, right? You will just you will have capital gains, only capital gains or capital loss, depending on how the house value behaves, right? If the house value moves up, of course, there'll be ups and downs, right? Some years, it goes down, as you can see. So growth rate is negative. Some years, it stays flat, no change. Some years negative, right? But overall, there was a capital gain of 350K over 11 years. That's scenario 1. And in scenario 2, you have not only capital gains, but also additional income. Why? Because you bought this as a rental property. So you rent it out, right? As you rent it out, there will be additional income. Of course, there will be ups and downs in house values, right? So at the end of your holding period, at the end of the holding period, you will have capital gains and sum of all the cash flows, right? So all of these are capital gains and cash flow or additional income, cash flow from additional income. They are the sources of your return. Two factors that mainly determine your holding period return. So we found our holding period return in scenario 1 and in scenario 2. Basically, this, in scenario 1, it's because there is no additional income. You just, follow the definition of, holding period return, which is, PT plus N minus PT. In our example, PT plus N is P 2016. PT is price P 2005. Okay, price at the end of 2005. And then this term drops out because it is 0 in scenario 1. And you divide it by PT P 2005. So that was exactly what was done there, right? B2 is the price at the end of 2016. B5, right? Price 2005. B13, right? B13. Or you can do it that way, or you can do it this way, because we already have, what is C14? C14 is already, sum of all the, C14 is already this minus this, right? The only thing is, in column C, I found, year to year capital gains, right? Year to year or annual capital gains, right? Sum of all of that must be equal to this minus this. So that it is. So I just did it like that. In scenario 2, because there was, additional income, right? I added additional sum of all of that, sum of all the cash flows, which is in D14, right? So I got that. Also, since these are the sum of all the capital gains, between 2005 and 2016, right? Then plus the sum of all the cash flows between those 2 years, between 2005 and 2016, right? So then, we come to the same conclusion. And we tried out arithmetic average, right? First, in column E, we calculated return in scenario 1 year by year, right? So these are annual returns, right? But it's exactly the holding. This is the return with 1 year holding period, right? This is the 1 year holding period return. The year by year return is basically when holding period is 1 year, right? Year after year. So, and on the scenario 1, so, because there's only, capital gains, you divide it by previous year, right? And then drag it down, we get all this. In this case, this is the return in scenario 2, of course, year by year, right? And then, we drag it down. And for the first 3 years, growth rate and return must be the same because for the first 3 years, you didn't rent it out, right? There was no rental income. So I told you, basically column E and column F are the same thing, same concept. They are both returns. But, the only difference is column E is scenario 1, right? There's no additional income. So therefore, the source of the return is only capital gains, right? And column F, source of the return is both capital gains and rental income, additional cash flow. So that's the difference, but they are both, 1 year holding period return, right? 1 year, year by year. So if you want to take arithmetic average, if you take arithmetic average, simply, this is, what you would do for arithmetic average. But I told you, arithmetic average is overblown. It's overstating the true average because you cannot use arithmetic average in this case. I've been telling you. Anything that is growing over time, and I told you the difference between the longitudinal data and latitudinal data, because longitudinal data is also called time series data. So anything that grows through time, anything that grows over time, because of the successive compounding effect, you can't use arithmetic average, right? Arithmetic average and simple average is, for the latitudinal data or cross-sectional data, right? So if you use, arithmetic average or simple average, then it overstates the geometric average, Okay, so I did geometric average here. I gave you the formula for geometric average last time, right? Formula for geometric average is I derived it, right? PT plus n over PT over 1 over n raised to 1 over n, right? PT plus n over PT raised to the power of 1 over n minus 1. Okay, but this geometric average can be used only in scenario 1. I used, okay. In scenario 2, so that's, we all know B2 is the final, final year price divided by initial year, beginning year price, right? Raised to 1 over that. I told you that's the universal machine language, right? The symbol, het, cone, they have many names, hat sign, cone sign, or whatever. But the official name is caret, right? Caret. But that's the universal language for raising something to power. And so raised to 1 over, we know it is 11 data points. You can, you can physically count, but that is a stupid thing because think about it. When you have small number of data, it's possible, but if you have hundreds of data points, thousands of data points, you can't simply do that. So in that case, then you will need to use, either count command. I will, use count command and just highlight these, data range, and it's going to automatically count. Or you can do 2016 minus, because all these prices are indexed, right, by year, right, indexed by year. This minus this will give you 11, and minus 1. But again, as I said, this can be used only in scenario 1. Why? Because you can tell from the formula it comes from this formula, and so you have PT plus N and PT, but where is the cash flow? There is no cash flow reflected, no sum of the cash flow, right, reflected in this formula. And then, therefore, it is not appropriate. It's not appropriate formula for. That's not the fitting formula for scenario 2. So in scenario 2, what do you need to do? You will need to use the. There are two things. In scenario 2, you can use, this formula. And what is that formula? It's gonna be a long story. I'm not gonna. It's product of all. So before we get there, let me talk about Excel's built-in command, right? Excel's command for geometric average is Geo Mean. Geo Mean. Would mean, that obviously geometric average, right? Geo Mean. And then to use Geo Mean, you will need to use 1 plus R. You cannot just use R only, right? 1 plus, and you must have noticed, once I have column E and column F filled in automatically, right? Filled in, then column H and column I automatically populated. Why? Because column H and column I, by definition, it is exactly 1 plus G. So it's 1 plus G, 1 plus R. This one is 1 plus R. So literally, 1 plus R. And then you drag it down. All that is, already built in there. So it automatically populates, right? It will automatically populate when the data in here in column F data are populated, right? Column I is populated. When column E is populated, column H is automatically populated. So then what do I have here? I have product of I2 through I12. Product is multiplication, right? So When you do that, that means this times this times this times this times. But yeah, so that's the product, and that is the that's what is in this formula, right? Product of all those terms raised to 1 over n minus 1. So then, what is 1 plus g and 1 plus r are gross rates, gross return, gross rate, right? Gross rate of return. Now think about it. The reason we subtract 1 here is we subtract 1, right? And also in this formula, we subtract 1 as well. Why do we subtract 1? Now, think about it. We have, if your annual income was $10,000 last year, and your annual income this year is $15,000. Now, how much did it grow? How much did it grow?
You said the initial was 15?
No. Initial income, your income last year was 10K, 10,000. This year, 15K. So how much did it grow?
5,000.
50%.
50%, yeah. Yeah. Who said 50%?
Me, Edgar.
Edgar, okay. So Edgar, I'll give you 0.25 for that. Yeah.
Oh, word?
0.25.
Say less.
Mhm. Yeah, that's extra point you get. That's the participation point you get. Now, I heard someone say 5,000, but again, yeah, that's it grew by 5,000, but in percentage, right?
I said 5,000.
What?
I said 5,000.
Yeah, and who was that?
Eva.
Eva. Okay, Eva. I'll also give you 0.25, but look, it grew by $5,000, but it's 50 in terms of rate of return. We're talking about our topic title is what? ROI, right? Return on investment. All this time we've been talking about how return should be expressed. It must be rate of return. So I will still give you 0.25 for that, but always
Thank you.
think in terms of rate of return, right?
Okay.
So so it grew 50%, but 50% is net growth rate, isn't that right? It's net growth rate. You can also say in gross growth rate, in gross return, it is this year's income. This year's income is 150% of last year's income, isn't that right? This year's income is 150% of last year's income. Isn't that right? Isn't that right?
I think the confusion is where are we starting at? Like what number? Are we starting at 10,000?
Okay,
Still using that example?
Who is that? Who is that? Can you speak up, please? I can barely hear you.
That's Peter.
Peter? Yeah, can you speak up? I couldn't hear you.
Had to
So
change my mic. I think that's what was messing it up.
yeah, I think you need to raise the volume of your microphone.
I took off the AirPods, but I think the confusion came in from where we're starting point at, like the starting point of where
The starting point is last year's income. Last year's income is 10K.
Okay,
Between
so
last year and this year your income is, of course, all these data are collected at the end of the year. Think about it. You cannot say last year's income in the middle of last year. Isn't that right? It's always at the end of the year. So if you say this year's income is 15K, that's also collected at the end of this year, because you cannot say in the middle of this year your income this year is 15K, right? So over 1 year period, And I already gave you this scenario. This scenario is your last year's income was 10K. This year, 15K. So that's why, the growth was 50%. But you can also say this year's income is 150% of last year's income. Isn't that right?
Yes.
Yeah. Then, if you say it is 150%, that means that's the gross growth rate, gross return, or gross growth rate, right? The net growth rate is 50% only. So to find the net growth rate, what do you need to do? You must subtract 1 from it. You must subtract 1 from the gross growth rate. When I say 1, it doesn't mean 1%. 1 is 100%, isn't it right?
Yes.
So if you subtract 1 from it, then you get the net growth rate. Make sense? So that is why all this, that is why there is, minus 1 there. You must subtract the 100%, the initial value that was there, right? Think about it. Here we subtracted the initial value. If I didn't subtract it, it would have been 100% more, right? Think about it. If I didn't subtract it, it would have been like this. But if you subtract 1 from it, right? That's the net return, right? Makes sense? So that's why there is minus 1. So again, this is the geometric average formula, right? For scenario 1, right? In case you have, and this is the geometric average formula for scenario 2 will have to be like this. But don't worry about that just yet, because it's a long. It's not at this point it's not really necessary. And if we need, if ever we need to use geometric average in scenario 2, you may use Geo Mean, okay? But but to use Geo Mean, right, you have to have 1 plus R, right? The data must be in gross return form. You understand? In gross return form. These are net return form, right? But these are, because it's 1 plus R, 1 plus G, they are gross return form. And then you can use, Geo Mean. All right. Now, then you, at this point, you might just, it's hard at this point, all you need to do is just, you'll have to memorize this formula and use it. But then, how did we arrive at this? I mean, how did we come to this formula? So that's what I want to talk about today. So let's think about it. We know the house value of 2006, right? The house value of 2006. And this may not look like 6, but oh, they took out everything. If you think about it, The house value 2006 is the result of the house value 2005 times 1 plus growth rate in year 1. Isn't that what it is? 2006 house value is 20% growth, result of the 20% growth from 2005 house value. And you check it out. You can easily check it out. I'm gonna, let's do it here. Because I already have. You can do either this times 1 plus G1. G1, what would that mean? That's the growth rate in year 1, right? G1, G sub 1, G subscript 1. That all the time subscript, it simply indicates they are time markers. It simply indicates the time. And you get exactly that. Or, because I have already 1 plus G here, right? I can simply use, that 1 plus G, which is an H12, right? Okay? And think about it. You can do the same, right, as you go up, right? And what is that? Exactly, a previous year, right? Times 1 plus growth rate in year 2, right? And so on. You arrive at so you arrive at 2006 price by 2000 multiplying 2005 price by 1 plus G1, and then 2007 price is, then we just saw that 2006 price times 1 plus G2, which is growth rate in year 2. But then what is 2006? Price 2006 is actually, this is the definition of 2006. Is that right?
Yes, because when you multiply, you get the profit from that year.
Right. Because 2000, yes. Price 2006 is simply, this is the definition of 2006. You can simply replace it by, right, the definition of that. And we can keep going. And then if that's the case, I didn't write it here, but, we know what it's going to look like. Price in 2007 is price in 2005 times 1 plus G1 times 1 plus G2. And then price in 2008 is 2007 price times 1 plus G3, growth rate in year 3. But then 2007, P2007 can be replaced by its own definition, which is P2006 times 1 plus G2. So I replaced it by that. And then, so this one is replaced by its own definition. And then 1 plus G3. Okay, so this is, and then again, 2006 can be rewritten by its own definition, which is 2005, price 2005 times 1 plus G, right? And then, because it's 2006, right? And then, 1 plus G2, and then 1 plus G3. So look, what is going on here? This is like the snowball effect. Remember, this is the compounding effect. Because at the beginning, the snowball was P2005 at the beginning, right? And then it picks up, it grows by, it picks up more snow. It picks up snow as it makes, it rolls down the hill. The first revolution, right? the first revolution. At the first revolution, it picks up the snow by the rate of this, by the rate of G1. So now it's the P2006. And as it rolls down the hill again, in the second revolution, it picks up the snow by the rate of G2. The snowball is, obviously not very smooth early on. It's rugged, right? So because it is rugged, the growth rate, in other words, the rate at which it picks up more snow, is all different. Now, if we keep going like this, eventually, now let me take you to. Now think about it. This is the, you see, P1006 is, P1005 times 1 plus G, P1007. Now, P price in 2016 is basically, price 2015 times 1 plus growth rate in year 11. Growth rate in year 11, which can be rewritten as starting from the fist, a small fistful of snow, right? The initial snowball on top of the mountain, and it grows by G1 in the first year, grows by G2 in the second year. So eventually, 2006 price can be rewritten as P2005 times 1 plus G1 times 1 plus G2, going all the way to G11, right? And to generalize it, right, it will look like this. PT plus N is PT times 1 plus G1 times 1 plus G2 times 1 plus G3, and, all the way to 1 plus Gn. 1 year before N is N minus 1. 1 year before N minus 1 is N minus 2. So whatever N may be, right? If N is 60, this is going to be, 59, 58, and so on, right? So then, think about it. The growth rates are all uneven, right? In reality, no growth rates can be even, right? I mean, that's the reality. So that's why we want to find the average, right? Because all growth rates are uneven, right? All growth rates are uneven. So that's why we want to find the average. And if we find the average, it will average is even, right? And we get to the same result. Think about it. Now, so this is what it means. This means for all t, for all the time, for all time, right? Regardless of 2005, 2007, for all time where this I is not equal to j, I and j is just representative of any year. So like if I is 2007, j could be 2008, right? Any random year within our time holding period, within our time range. So that means for all time where time 1, time 2, time 3, time 4, time 5 are not equal to each other, that means our time subscripts are all different, right? They all vary. So our time subscripts are actually, 2005, 2006, 2007, they're all different, right? But for all of those, different times, if growth rate in year I is equal to growth rate in year j, right? For all of those times, right? And they are all, if they are all the same, if they are all equal, then we don't need time subscript anymore. Now think about it. Under what circumstances can all growth rates in each different year will be the same. It can happen only when we have found the geometric average. If we found the average, think about it. If we found the average, then we can we don't need time subscript anymore. We can simply, and we arrive at the same result. Think about it. G1 is equal to G2. It's equal to G3 because it's average, right? Now, with the average, if you drop the time subscript, lose the subscript, then it's going to be all 1 plus G, 1 plus G, 1 plus G, 11 of them. 1 plus G times 1 plus G, 11 of them. Right? And then we arrive at the same result because it's the we are using the average from all of these different growth rates. So if we use the average, we arrive at the same result, right? We will arrive at the same result, and that's the mathematical fact. But then think about it. When we don't have any time subscript, then they are all 1 plus G, 11 of them. Right? It's going to be 2005 times 1 plus G times 1 plus G times 1 plus G, 11 of them. And we know we don't write it like that. When it is 1 plus G, 11 of them, right? Then the better way to write it, we know it's going to be 1 plus G raised to the 11th power. Right? Everyone understand?
So you're just simplifying it. Instead of just writing G1, G2 all the way out, you're just making it like one.
Yes, exactly. Yeah, think about it. If we have found the average, right? If we have found the average, then we can replace all of these by the average. And because average doesn't have any time subscript, because it's the same no matter at what point in time, it's the same thing. And then we will have multiplication or the product of 11 terms of 1 plus G. And then there is no reason to write 11 terms like this. You would have to write 11 terms when the G1, G2, G3, all of them are all different, right? Because they are all different. You cannot just, contract them into powers. But now, when they are all the same, you can simply, it's going to be P 2005 times 1 plus G raised to 11th power. Make sense? You don't. So now we arrive at the generalized notation here. Once we have found the average, then PT plus N can be simply expressed by PT times 1 plus G raised to N. In other words, these long these long 11 terms can simply collapse into 1 plus G raised to 11. To generalize it, PT times 1 plus G raised to N. Okay? Does that make sense? Everyone can follow? Now, hence, now from this, now think about it. Our question is then, how do you find G? I mean, we started out with the assumption that we have already found G, the average, right? But then how do we solve? How do we really find G? And then that's the math. It's simply algebra. So because based on this, and I'm gonna have to, it's gonna take a lot of time, and there will be in the third topic, there will be the time we talk about the actual process of deriving steps of derivation, right? Deriving G from this formula, but why we have to raise it to 1 plus N. It's going to be discussed in topic 3. But for now, from that, we have to we can isolate G, by doing this. Okay. Now, first of all, we need to isolate G. We cannot do that with the exponent, because the exponent is like a padlock. So we have to free up. We have to open this padlock. The only way we can do that is by taking the nth radical on both sides. And if you take the nth radical on both sides, then this gets freed up. Then you can move the 1 to the other side and isolate only G. Okay, so and this is why we have another way when we use gross growth rate, right? Then why we use the product of but that we don't have time for that right now. And although this is the same steps of derivation, but this one will be explained further. I believe I did this. I think I did that in some in summer session, but not at this point, but in topic 3. Alrighty, so that gave you the explanation for how this formula is derived. For now, the formula for geometric average is this. Okay, this is the formula for that. In the practice test, there will be a question about geometric average, and it is no further than this formula. In other words, it's scenario 1, geometric average under scenario 1. Okay. Alrighty. So that wraps up everything about the first part of ROI, the videos number 1 through 6. Let's see how many people are here. 9, only 9, and yeah, that means 9. I mean, okay, 9 people in the collaborate session, and okay, so 9. I mean, this class has, I believe, at least how many people? This class has something like 20. Let me check. Oh, come on. Okay, also 1400, 22 people, and only 9 are here. This is a disaster. And especially with the practice, although it's a practice test, with the practice test, ahead. So now let's move on to. So actually, today's. Let me get to. Today's videos are. I mean, actually, ROI and macroeconomy, part 1 through part 3. That was last the lecture for the last Thursday. Today it's part 4 through part 6. Now, so we're a bit behind, but that was already given. That was assumed because we are reflecting. So Now let's think about the how return on investment is, how to understand return on investment in the macroeconomic context. Of course, in macroeconomic context, the most basic and most lowest, the lowest rate of return on investment is the interest rate. Okay, and interest rate is the if you think about it, the riskless return on your money, right? Riskless return on your money. And when you put your money in the bank, right, you may never think about it. You may never consider it as investment, right? But it's an investment if you think about it. It's a riskless investment. Riskless. Why? Interest rate is always guaranteed. Interest, and that's why interest on your deposit is the lowest in all types of all kinds of return on investment. And of course, money in the checking account doesn't earn any interest. Some banks offer interest-bearing checking account, but it will be very, very even savings account is supposed to give you interest, but these days with zero interest rate, right? With almost zero interest rate, zero, a benchmark rate, you put your money in the savings account doesn't give you anything, not even 0.1% a year, not even 0.1%.
It's more like 0.001.
Yeah, 0.001, 0.0. Yeah, it's more like 0.01, 0.01. I mean, in percentage, right? 0.01. So it's so mediocre, it's so immaterial, we don't even perceive. But there was a time. There were times when interest on the savings account was at least something like 3%. Even in the early 2000s, between 2000 and 2006, 7, and so there was a time also when the interest on the savings was as high as like 15%. You might wonder, how can yeah, it happened really during early 80s. During early 80s, the savings account was paying maybe not 15%, but at least something like somewhere between 10 and 15%, something. That was between 2000, 1980 and 84, 85. But you might say, wow, that was that must have been a great time. No, it was not a great time for the economy. I mean, for the savers, it was a great time. But then for the economy, it was a bad time, really bad time. Why? When interest rates are high, the economy gets depressed. Then you might wonder, why did they intentionally, during the early 1980s, did they intentionally depress the economy? Yes, they intentionally, actually, they wanted to depress the inflation. They wanted to cool off the economy, to tame the inflation, to kill off the inflation.
So if they do that now, then shouldn't they do it now?
No. They are actually no. Inflation is still very low. Inflation is still very low. I mean, if inflation is very high, no, inflation is just around 2% range, or overall inflation. You might say, oh, if you go to the supermarket, if you go to I mean, the grocery is so much more expensive. Only groceries, only groceries. I know if you go to the supermarkets, uh, groceries are about 33% more expensive than last year. So only for groceries, but overall inflation is still less than 2%. And that's why the interest rates are so low now. And the reason is, by keeping interest rate low, they are trying to encourage borrowing, and the more borrowing will stimulate the economy. This is, so we are now into the realm of macroeconomics. So I've been telling, so I was telling you, the we are having very low interest rates now, and it's been like this since the last financial crisis in 2008, right? Right after 2000, right after financial crisis. Look, okay, this tells you. Look, this is January 2006, and January 2006. Where is the Fed funds rate? Fed funds rate is the benchmark interest rate for all interest rates, for bank interest rate, for short-term bank interest rate. It was, like 4.25, and then 1 year later, in July of 2006, where was it? July of 2006, it was 1% higher. It's like 5.25. And then January of 2008, it was still 5.25. But 1 year later, January 2009, where is it? It says 0.25, and it was held at 0.25 until January of 2016, and then they raised this slightly to like 0.5, and then since then they raised it to they held it 2017. It was January 2017, it was at 0.5%, but then by December 2018, it was between 2005 and 2005. But now 2020, since the pandemic, then it came back to 0%. It's between 0 and 0.25, back to like December 2006, and I can't get rid of. Okay, if I have a cursor there, it's blocking the. Okay, you see. right? So, and the reason the rates are low, so why? Now let's think about it. So when we say interest rate, I told you, it's the riskless return on the money. So if it is riskless, that means, any investing involves risk. There's no risk-free investing. Of course, if you put your money in the bank, it's risk-free. And if you put your money into U.S. Treasury bond, Treasury bills, Treasury securities, it's almost risk-free. But if you put your money into stocks and bonds, then they all have some risk, right? And stocks have, of course, much higher risk than the bonds. Bonds have, more, less risk than the stock. But some bonds are also risky. I would say risk is moderate. For bonds, risk is moderate. And it's much more predictable than the stock. Now, lending, so interest rates are basically classified as lending rate and borrowing rate because, now think about it, when you put your money in the savings account, and of course, savings, there is, another, there are CDs, when we say savings, because these days, interest rate on the savings is like even 0.01%. If you want to get something on the on your savings, you better put it into CDs, certificate of deposit. And of course, certificate of deposits these days don't even pay, I think, not even pay 1% these days. They don't pay 1%. In 2019, 2018, they were paying like the highest paying one was even paying like 2.75 or even 3%. But these days
Treasury bonds. You said Treasury.
No. CDs.
Oh, CDs.
Yeah.
Oh, okay.
Yeah, CDs. Back in 2000, I'm talking about 2018 to 2018. No, these days no more. CDs are not paying even, CDs are paying, not even 1% these days. But CDs,
aren't they like
CDs,
-3 yielding because like cash decreases like 3% or something, or 4%? I'm assuming.
Yeah, I mean, if you no, cash doesn't decrease at that rate, because if cash is decreasing at 3%, that means inflation is 3%. But inflation isn't 3%. Inflation hasn't hit 3%. Inflation is at best, like 2 point something at most. But still, I mean, think about it. That real return is. I mean, if you get 1% on CD, but if the inflation is 2%, you get, your net return is negative 1%.
Yeah.
Right? That's called real interest rate. Okay, I'm gonna get to that concept, but yeah. But again, what I'm talking about is, because it is risk-free, at least, right? Risk-free.
Yes.
But,
comparative to like a 5% Bitcoin allocation, because that's like the risk.
Yeah. It's I mean, look, Bitcoin. Bitcoin is really, it's super risky. Okay,
The
Bitcoin
next big thing. Watch.
No. Look, you are
Buy Dodge.
really. Say it again.
He said buy Dogecoin. He's right
Buy
though,
Dodge.
because to be honest,
Buy
right
Dogecoin.
right now
Look.
it's already big because it's worth.
No,
40,
look,
50
no cryptocurrencies are safe. I mean, you gotta, set your foot into that. I mean, if you're wading in the water, you gotta know that you're getting into a very, very deep water. It's a very, very
Yes.
deep water.
Absolutely, and if you go in
That's
there
true,
with,
Professor.
and 50%
your expected return from Bitcoin, it will be negative. It's not positive. I mean, expected return meaning, the average. If you take the average, from the past, Bitcoin returns, it will most likely come out as negative. But again, some people may get lucky, but that may not happen to you. It's like buying a lottery.
Yeah,
but
you're
in lottery,
right.
you
The short term
it's
people,
absolutely
they definitely don't make it through day trading.
exactly,
But
exactly.
the hodlers who hold over a 5 to 10 year period, those people are up 20,000%, 30,000%. And it's very
But if
difficult to hold through that period of time.
exactly,
through a
you
bear
must
market.
you must weather all these ups and downs, and you don't have, most of you don't have that perseverance, you don't have that patience. You just want to, when the price falls, you just panic and you sell,
Yep, and
right? And
they
you just
capitulate. They're not
you just realize negative return, big negative return, right? So look, at least if it is lottery, your stake isn't that high. I mean, you buy only, you spend like $20 on lottery, right? And your expected return is always negative.
We have Paul Tudor Jones as well. A lot of big hedge fund people are allocating a small percentage of their portfolio. They're not allocating 25 or 30%, but they're doing 5%, and they're outperforming the rest of their other portfolios. So it is good.
I mean, if you have, look, if you, are you saying if you have, some people, if you have like 5% of your portfolio in Bitcoin? Yeah, of course, if you have only about 5%, if you have only about less than, I would say, just to be on the safe side, I would say less than 5%. Of course, you gotta, there should be, your portfolio must consist of riskless assets, and risky assets, and among the risky assets, some bonds, and stocks. And as long as you have sufficient risk-free assets as treasury bonds, treasury bills in your portfolio, and more than 95% of your portfolio is
riskless.
If the allocation is like about 45% of your portfolio is riskless, and let's say the other 50% is risky assets, which consists of stocks and bonds, and less than 5% is Bitcoin. You're not gonna.
That definitely works. That's becoming the new portfolio.
That's basically your portfolio is in a way hedged, right? It's not a perfect hedge, but in a way, some concept of hedging is diversification is a way of hedging.
You're right, and it definitely to the storyline.
If you put all your money in Bitcoin, please don't do that.
Don't do that. Yeah, don't do that.
If you put significant, if you not even all, but significant a portion of your money into Bitcoin, that's a stupid thing. It's like putting in all your money into a slot machine, and sometimes you may win. But people who, let me tell you, the expected return from slot machine or from lotteries are always negative. Expected returns are bound to be negative. Sometimes you may get lucky, but expected returns are negative, bound to be negative, right? So, but what I'm saying is, at least if you're buying lottery, you don't buy more than $20. I mean, so your stake isn't that high. Your stake is low. It's not a big deal. You just lose $20. That's negative 100% return. But look, where was I? So CDs, CDs, that's risk-free, right? But again, the return these days, I've been telling you, back in early 80s, return on the CDs, return on the savings was as high as even 15%. There was a time like that. Even early 2000s, some CDs paid 6%. Even early 2000s. But there's nothing like that these days. So even though it is risk-free, interest rate on the savings account or CDs are not really something to talk about. But theoretically, by definition, they are risk-free. But again, when we talk about the return on the money or interest rates, there are two types of interest rates. One is lending rate and the other one is borrowing rate. Now, lending rate means when you put your money in the bank, right? I'm sorry. When you put your money in the bank, it's called the borrowing rate. Why? You're not borrowing, but look, the bank is borrowing from you in that case, right? So borrowing sounds like, you are kneeling, you have to beg, kneel on your knees, beg, please, lend me money. No, lending and borrowing is actually these days, you're not borrowing from mafia, right? You don't have to kneel. If you go to the bank, right?
When you give the money to the bank, they lend it out to make money. A lot of people don't know that.
Yeah. Banks lend out money to bank's main business of the bank is to lend money. They make money by lending money. So when they lending rate is when you borrow actually from the bank. So why is it called lending? From the banking industry's perspective, they are lending. So it's called lending rate. But when you are putting money in the bank, you're saving, you're making a deposit, then it's called borrowing rate because the bank is borrowing. You may never thought about, you may never thought you are lending to the bank, but when you put your money in the bank, you are passively lending to them, and the bank is passively borrowing from you. Right? Does that make sense? Without really, thinking that you are borrowing, you are lending, or they are borrowing, but they are effectively borrowing. So it's called borrowing rate from the bank's perspective. Now think about it. Then when you put your money in the bank, you don't even get 0.1% a year. You don't even get 0.1% a year. But when you are borrowing from the bank, it's a totally different story. Totally different story. Your borrowing rate could be anywhere between 3 point something, or let's say 4% to even 10-12%, whatever. And why is this so different? It varies depending on your credit score. Okay, if you have high credit score, then you are highly credit worthy, and you are low risk. You're low risk to the lender, so they don't have to charge high interest rate. And if you have excellent credit score is credit score above like 820, and if you're in the category, it's like top 5% of the population. And if you are in that, if you have excellent credit score, you can, if you don't like their rate, you can always shop around. They don't want to lose you, so they will generally accommodate your demands, right? You are at a commending end. You're at the commending end of the bargain. Okay, and if you have a very bad credit score, you are a high risk to the lenders. So your borrowing rate will be, or from the bank's perspective, their lending rate will be very high. And so the difference between the lending rate and borrowing rate is called spread. And this is the major source of the bank's income. Now think about it. Where does the money, if you go to the bank and borrow $1 million from the bank, where does that $1 million come from? Where do you think that $1 million comes from?
All the clients, banks,
Yeah,
everybody.
it comes from someone else, right? It comes from another depositor of the bank, isn't it right? It doesn't have to come from just one individual. I mean, it's a pool of all the deposits from other people. But if you borrow 1 million, it comes from somebody else. It's someone else's money. But if you have a bad credit score, you borrow 1 million at 10%, right? But that 1 million came from someone else, and this person may have excellent credit score, or regardless of that person's credit score, he gets only 0.1%, right, on that 1 million. So what is the bank making? The bank is making 9.9%. That's the major source of income for the bank, right? Spread is the main. And then nominal interest rate versus real interest rate. This is the concept. One of you raised this concept. Inflation is 3%. And even if CD pays you 1% interest rate, actually you are 2% behind, right?
Yeah, you're negative. Behind. You're negative too.
Yeah, your return is actually negative. So we're out of time. So we'll have to talk about we'll have to talk about this on Tuesday. Okay, I don't know if Tuesday we have class again or not. But if there's that holiday schedule, and I have the holiday schedule. And then September. Oh no, this is just the.
We can't see anything.
No, this is college calendar. You can go to academic calendar, and this is just the screen grab. Oh, you can see that?
So the 14th is no class.
Huh?
The 14th is no class.
14th? Yeah, okay. Am I not sharing my screen? I'm sure I'm sharing my screen.
Yeah, it was up.
It's a lot. I see a lot of screens. I don't know.
Why is this so? September 15th through 16th. And yeah, we have 14th. We have class on the 14th. So that's going to be next Tuesday. So I'm going to see you guys next Tuesday. Okay. And please don't forget, you have practice test starting tomorrow, right? It's not visible there. It's not visible yet, but it's going to be visible. It's going to become visible at 12 midnight tonight. Okay. Alrighty, so take care, and I will see you guys on next Tuesday. Okay.
See you next Tuesday, Professor.
All right.
Class. See you next Tuesday.
All right.
Bye.
Take care, everyone.
Take care.
Take care, everyone.